Hello guys and welcome to Comprehensive Tutorials. In this video we'll be looking at other data types in C++. So these are my headers, and if you are not new to this channel then you would have known these headers by now. And then these are constants that we have defined, and so the normal one is always endl ending the line, most lines if you want a new line, but over here we're using a constant NL to denote a new line, and a constant T to denote a tab, and with the usual using namespace std. And this is part of what we'll be talking about in today's video, so just don't mind that. We'll talk about that later on. So yeah, so we'll be talking about other data types, right? So let's say that um, the usual data types that we have in C++ are the int, the float, the characters, and the strings, which are compound data types of characters, right? So let's say that for some reason, now C++ provides us with flexibility to kind of define our own data types and to even rename pre-existing data types. Let's say for some reason you can't remember that integers are the data types that are only for whole, positive, or negative numbers. So you kind of have a problem remembering that, or for some reason you just want to rename it. So the thing is, C++ allows you to rename it to whatever name that you want. So that's what we'll be looking at in the first section of this tutorial. So how do we go about it? So let's say that you want to rename integers, the keyword, into whatever name you want, and we want to say that we want to rename it to whole numbers. So how then do we go about it? This is the format. You have to use the keyword typedef. Whoops. So this is the format I'm talking about, and it's inherited from C, the C language, right? So this is C++ we're doing, and this format is inherited from the C language. The second format we'll be looking at is the C++ format, right? So the first way is to use the keyword typedef, and then the existing type we want to rename is the int, and the new one we want to name it to is hnum, to denote whole number. So a whole number can be positive or negative, so we just want to rename it integers to whole numbers, right? So we have renamed that, and let's say that we want to rename characters as well. Type def character, CHAR, and we want to just, for simplicity, let's just call it letter, right? So we have renamed it, and let's say that I want to declare a variable a, which is an integer, and it's to store 8 or whatever value we want. In this case, we can then replace int with whole num in that order, and then we can replace, let's say we want to declare a character, so we can say letter, and we can just call it L1, letter 1 is equal to, and the character, it's, let's say, Y or anything that we want. So we just run this, we should not be getting any compile time error, right? So that's how to kind of rename it. We're not getting any output because we have not asked it to print. So let's just ask for an output to be sure that this is working. So a tab and L1, right? New line. So we run this, and it's going to print the value of the variable a and L1. Okay, so after the tab I should have those signs over there, right? So we have 8 and Y. Good. So this is working perfectly. So we just renamed the pre-existing data type. So after renaming it, you can do whatever you want with it as if you were working with the original data types, right? So whatever you can do with integers, you can do with W numbers, and whatever you can do with characters, you can do with the renamed format letter, right? So now let's look at the second way of renaming our pre-existing data type. So the second way is the C++ format. And what we can do is you can use the using keyword, and then the new name that we want to give, let's say to doubles, is going to be decimal numbers, right? So dnum, WNUM for whole numbers and dnum for decimal numbers. So we want to assign it to doubles as such. And then we want to rename strings as well. So using, let's say, word, and we want to say that should be equal to string. Right, so we have reassigned doubles to be dnums and strings to be words. So let's say I want to declare a variable called anything, and I can just say dnum. Usually it's double, let's say double num1 is equal to 0.9, but in this case we have renamed it so we can use the dnum, right? And then let's say string sentence. What is a sentence? Let's just say greet, and this is equal to hello world. Hello world, right? So now we can replace the string with word as well. But let's just run this to see whether after renaming it works or not. Okay, so it still works perfectly. Even after renaming, you can use the pre-existing format as well. But let's just go ahead and then, or let me leave it and then print it so that you guys will see what I'm talking about. So I'll undo this and then see out, print it out, right? So we want to see out num1, right? And then after that we want to issue a tab, and after that I want to print out greet, then after that a new line, and we end it there. Right, so we should be getting 0.9 hello world. Good. So whatever you can do with doubles, you can do with dnums as well. Now one thing I want to point out is that we have subtypes under the various data types. So for instance, we have signed short integers, signed long integers, unsigned short integers, those kind of subtypes. And you should know by now that integers are not the same as ints is not the same as a short int or an unsigned long int. So for each and every one of the data type that you want to be using, you want to explicitly rename it. So for instance, we can say short int. So we can say using let's say SSI to be equal to short int in that format, right? Because short int is totally different from integers based on the amount of storage they occupy. So based on this, you want to explicitly rename each and every one of them that you will be using, right? Or you could have just said I for integers, anything, whatever that is easy to remember, or however convenient the name is, then you can use it, right? So we want to look at union right now. So what is union of data types? Now it's almost like the structures that we looked at in the previous video. Yeah, it has the same format as structures, right? But then the only difference is that for structures, the various elements are stored on separate memory addresses on the computer memory. But with union, they are stored on the same memory address, at the same memory address, or on the same memory stack. Now, why is this useful? Now, because they are stored in the same memory stack, it's useful because, let's say, in systems where memory is a very valuable resource, for instance, in, let's say, the computer that you are using right now, comparatively, it's a larger memory to other systems like embedded systems in TV, systems in radios, and the most common that probably most of you guys would be familiar with is the Arduino chip. Now, why this is necessary is because they have the same memory address, then whatever variable that would be stored over there, it is going to be the latest value that is going to be worked with. So I don't know, maybe after an example then we explain better, because abstract things are quite easy to forget. So let's just create a union. So I just made up one over here, so I just uncomment that. Right, so this is the structure, but before we look at that, let's just look at the structure of the union, how to declare it. We know that this is the format of a structure. Let's say structure participant, which we did in the participant, right, in the previous video. And we can have an int age, and we can have the string name, right? And then you come out over here and you create your first object called person A, or you can also say participant person B. Whoops, I mistakenly pressed shift B. So I wanted to make this capital B, but on my keyboard the shortcut shift B it denotes run, it denotes build and run. So when I press that, it just runs. So I should use caps lock B so that we can get the B over there. So participant person B, right? So this declares, or it creates an object as well. You can use this format, you can use this format as well. But let's just clear this because we're using the first format. So this is what we call a structure. Let's run this to be sure we have. But before then, let me comment this out. Right, so I just go ahead, comment this out, and this is what we have so far. I think, yeah, we will not be using these, so we just commented out the couts. So this is the format for a structure. So we run this to be sure we don't have any compile time error. Right, now this is the format for a structure. Now let's look at the format for a union. The only difference is that you replace this with union and the functionality changes. The object declaration is the same, right? So this is the only difference. You change the structure keyword to union and the functionality changes. So we just clear this and then we go up here and work with what I made up earlier. Right, so we have a structure, not a structure, a union called product, and its members are integer, price, and double weight of the product. And then we came out and we declared an object called chocolate, and this chocolate has a price member, it has a weight characteristic as well. So we can go ahead and give values to these members, but because of this video, we'll not be doing that. You can go ahead and put values in there, print them, or whatever. You can work with them in whichever way that you want, just like structures. But I want to look at the major functionality that differentiates union from structures, right? So now the only difference is that the members of a union are put on the same memory stack, but for structures they are put on different memory stacks. So because of that, let's create a structure as well. I think I shouldn't have cleared the other one. So structure, we want to call this participant, and then we want to say this is a string name, right? And then int age, and then what we want to say is person A, right? So person A. So this is a structure and this is a union. So we'll be printing the memory addresses of each of the members to compare them to be sure that indeed they are stored on different memory. They are stored at different memory addresses, right? So let's go ahead and then we have created objects. You have chocolate object and then the person A as well. So let's go ahead and create pointers for that, and we have looked at that already in a previous video. So now let's create the first. This is chocolate, right? And we have chocolate dot price, which is an integer, right? So now I want to create a pointer for this one. So the data type over there is an integer, and then we want to call this pointer p1, and we want to assign it to the memory address of chocolate dot price. I hope you got the syntax. So this is the object or the member whose address we are interested in, and it's we this sign over here is the address of operator. So we said the address of chocolate dot price, we should put it in p1, the variable called p1, and this is just the data type of the whatever is stored in this name, right? So, and it's an integer. If you look carefully over here, where is it? Right, it's an integer. So we go ahead and just copy this and paste, copy and paste it over here. And we want to have p2 over here to be chocolate dot, I think is weight. Even this one helps in helps you to complete the names, because when we put the dot operator over here, we have the various characteristics of the object or the various members of the union that we have created, and this is a double, so weight, and I'll go over here to change the n to double, right? So this also helps you to check out things. So we created 2 pointers for these objects. Let's go ahead and create the other pointers for the other one. So I would say it's person A dot, and age is an int, right? So I'll go ahead and create int of p3. We are assigning it to the address of person A, and then the last one we have is a string, definitely. So string, and p4, we want to assign it to the address of person A dot name, right? We can go ahead and put in values over here, but we can go ahead and assign values to the chocolate dot price, person dot age, but that's not what we are interested in. We are interested in um, getting to be sure that the memory addresses are different. So we go ahead and then we see out. Now further, let me run this to be sure we have no compile time error, right? And we're good to go. So let's print out these pointers. So see out, and we have p1, which is the memory address of chocolate dot price, and we want to have a tab over here, and then p2. Then after that we want to issue a new line. But to make this meaningful, let's put a sentence here. So we say the pointer for price, let's say pointer for price, right? So pointer to price, yeah, let's just put it that way. Pointer to price is p1, and pointer to, was it weight, right? Weight is p2. Then after that we issue a new line. Then want to print out pointer to age is, whoops, what have I done? Right, to age is p3, and pointer to name is p4, right? And we issue a new line, and we're done. So we run this. So we have pointer to price is this, and pointer to weight is this, and we can see that they are of the same, they are pointing to the same memory address. But for the structure, pointer to age is this and pointer to name is this. We can see that the ending is not the same. They have been put at different memory locations, but for this one, it's at the same memory location. Now, what is the advantage of this? As I was saying earlier, the union is mostly used in embedded systems where memory is a valuable resource. For instance, the Arduino chip, you have microprocessors in there, and you have a little storage capacity over there. Comparatively to the computer, it's little. Now, when you have this set up to take input from the environment, let's say you are measuring a variable like light intensity, you're measuring a variable like distance, anything that you're measuring. Now it's going to be taking the values as they come in, and it's going to be working with the latest value. So let's say that your measurement or your sensor kind of measured a value like 8 whatever, this is the value. What it can be in microseconds or yeah, microseconds. So now it's going to be coming in as in like very quickly, because the sensor is going to be measuring very quickly. Now let's say you want the measurement at a particular point. Now at that particular point, you're going to work with the value that was measured at that time, and so you get the value at that time. And when you want the next value, is going to be the value at the moment. Now when you want the value you measured let's say 5 minutes ago, I'm not sure you'll be able to get it, because it's only the latest value that you are working with. The memory is only um, small to kind of work with the latest value. Now to kind of illustrate what I mean, let me now that we have verified that indeed they point to the same memory address, let me just comment this out, and then we'll go ahead and then try to issue values to these members and to see how they kind of change. Right, so I'm going to copy this one, the chocolate, the price, and I'm putting it here. And then why did this thing, we'll see what I have done. Right, so I'm copying just you, copy, paste, right, and then copying just you, copy, paste. So I'm going to store in the value chocolate price. I want to just put in, let's say 78, anything, right? But then would kind of comment out this particular line. Why is this right? So we've commented out this particular one. Now we have chocolate the price is equal to 78. Let's go ahead and print this value out. So let's say that our sensor has measured this input, which is 78. So we are printing out chocolate dot price, right? And then we are printing this value, or we are working with this value at the moment, right? So the sensor gave us a value of 78, right? So when we ask the sensor to measure again, it's going to measure and work with the latest value. Now let's put a value of this to this particular variable, and now let's run this to see what happens to chocolate the price, and we have it at 0. Now mind you, we did not change the chocolate the price to 0, it's still 78. And the chocolate, we asked it to print chocolate the price after we changed the second member to 789, and it's given us 0 for the first one. Now what we can do to verify that this value is actually picked is, let's print out C out chocolate dot weight. So we run this. I should have added a new line because we're going to get a clash over here. So I'll put a new line over there. Right, so we run this. If you're kind of confused with the NL, you can just put in endl, right? So we have 0 for chocolate the price and 789 for chocolate the weight, right? So you can see that we are working with the latest value. So whatever computation you want to do, you are always working with the latest value, because the memory is not enough to store a lot of variables. Just the latest value is worked with. So when your system that you are designing is, if memory is a very valuable resource, then you want to use union and not structures, right? So that was union for us, and want to look at anonymous union, what is it and how to use it. So I'd go ahead and then just copy this. Let me cut it and paste it over here so that, yeah, everything would be commented out. Good. So now let's look at anonymous union. Now we have a union over here and we have a structure over here. Now to illustrate this concept, I would just want to duplicate this structure. So I'll copy it and then paste it over here. So we have two structures now. This is participant. Let's say participant 1. So we have difference. Participant 1 participant 2. So I'm just creating two structures, and this is string name, and this is going to be string name as well, but capital. And this is int age, and this is going to be int age as such. This is person A, and this is going to be person A. Don't mind, we are just trying to be kind of different, but we're not going to be using these variables as such. We just want to focus on the union. So I just wanted to kind of make these different so that we don't have a clash. If you will be confused because of the variables, don't worry, we're not going to use them. Right, so we have two structures, participant 1 and participant 2. Now what we want to do is we want to copy this entire union. In fact, let me cut it. I'm cutting it and I am pasting it in participant 1. So we have it pasted in here, and I am going to reposition this. Right, so we have union product, and it has members int price double weight, and the first object is chocolate inside participant 1. Now what we want to do over here is to paste it here as well, and so we just want to paste it and reposition these members. Right, but in this case we are not going to define any object, and then we clear out this, so we just have union with its members, and we clear out this one as well. So we're going over what I just did. We had two structures. Structure 1, let me do it this way. So we had two structures. Structure participant 1, and it has member string name and int age. Then we had structure participant 2 with string names and int age. Now the second thing we did is we put in a union over here. Let me just leave a space over there. We put in a union to be part of the members of the structure participant 1. And the union over here, we did not give it its name. We just put in members that it had, and then declared an object called chocolate. Now we put in a union here as well with members price and weight, and over here we're not going to declare any chocolate. Oh yeah, over here we're not going to declare any chocolate. Sorry about that. We're not going to declare anything, right? So I hope you're following me. But then for this one we have person A and we have person A. I think I should rename these ones because we'll be using them. So um let's say person A and person B, right? Let's say person A and person B. I think that's going to be quite different, right? Person B. Whoops. Shift B again, and this thing is running, right? So cups B, right? Okay, so we have two structures. Now we want to look at what is an anonymous union. I think I should just work up here because it's kind of clear to see from there, and after that I can copy it and paste. So then let's see what we have. I'm trying to reposition this so that you guys will see what I'll be doing. Right, so now the first thing we want to do is we have person A and person B. Now let's try to access this member over here, price, and the syntax is person A dot chocolate dot price. So you have to this is the object for the entire structure. So after declaring the object for the entire structure, then use the dot operator to access the object that you have declared for the union before you can access the object for the member of the union. So we would have person A dot, and we have the help over here. So we want to access dot chocolate because that was the object we declared, dot chocolate dot, and we want to access the price, and we can work with it however we want. We can put in a value. After that we can use the value in a function, use the value anywhere, perform computations, perform discount operations on the price if it's more than a particular threshold value, anything you want. But in this case I just want to illustrate the concept of how to access these and the anonymity of unions, right? So this is how to access that particular element. If we want to access the second one, we can say person A dot chocolate dot weight, of course, is equal to anything that we want, right? So this is not what is the anonymous union access. Now the anonymous one comes in structure participant 2, where we don't have any object declared here. So how then do we access this member price over here? Now it's just straightforward. You just have to say person B dot price or weight or whatever member you want, just as you can access person B dot age name. And mind you, if you want to access person A dot any of those members, this is the syntax. So we have person A over there dot, and it helps us. You can just go directly to the age, you can go directly to the name, of course. So let's just go directly, or let's go to the price and to see whether an error will be thrown. And of course we got an error over here. We can't access this directly. So we have to say person A dot the age. We can access it directly because it's not under any subunit. We can access the, I think we can access the structure one. We can access the age and the name, right? So we can access the age. Where is it? We can access the age and the name directly, but not the price and the weight, right? But then we can access chocolate directly as well. So let's just say we want to access the age directly, and we have that. Let's run it to see if we will have any error. And as you can see, we have no compile time error, right? So now the next thing I want to do is to now access the anonymous union. So we have person B dot, and we can access the age directly, we can access the name directly, we can access the price directly, we can access the weight directly, because we don't have any of those we don't have any object for the union over here. So you can just go directly to these members. So just as you can go directly to these members as well. So we would have, where is it? Yeah, we would have person B dot age. Let me use the other ones first. Person B dot price. Why is this disappointing me? Dot price, and we would have this, and person B dot weight. Yeah, we can just assign anything to it. So we run this to be sure we don't have any error, and we do not have any error. We've not seen any output because we've not asked for any output. So let's access this parameter as well. Not a parameter, but a member, person B dot, and we have, what have I done? Oh, I used the B again. Person B dot age. We can say this is that, right? So we can go ahead and print these values, use them to work however that you want. You can say that maybe you have a list of people, and if the age is above 78, you want to apply a certain commission to those old people. Or if you have people between the ages of 40 and um 60, you want them to pay this amount or kind of tax. I don't know, anything that you want, you can work with those values as well. So that was how to access anonymous unions. And the next thing we want to look at is enumerated types, right?